Hello, welcome to Coffee Break with Microchip Technology. Coffee Break is our ongoing forum in which we discuss new and evolving technology, all in about the amount of time it takes to drink a cup of coffee. I'm your host, Eric Glatfelter. Joining me in the studio today is our moderator, Aliyah Fahoud.
Thanks, Eric. And hi, everyone. Thank you for joining us today. We are currently live on YouTube, Facebook, and LinkedIn. And you can participate in today's episode by leaving your questions and comments in the chat, or you can email us at livestream@microchip.com after the broadcast. Don't forget to follow us on LinkedIn and subscribe to our YouTube channel. Back to you, Eric.
Thanks, Aliyah. A quick note before we jump into today's topic. At the end of the episode today, we'll be taking a minute to share some news about the evolution of our live stream offerings here at Microchip. On to today's topic, integrated actuation solutions, decarbonizing aerospace and defense. Joining us today are two guests, Amit Goel and Vinny Walsh. Welcome to you both.
Eric, great to be here.
Thanks. Let's get started. I often like to take one word out of the title and do a deep dive on it. Today's word is actuation. Amit, can you tell us a little more about what we mean by actuation within the aerospace and defense context?
Well, let's first try to understand, how the plane flies, and then, what's role actuation plays into it. So, with me, I got this, replica of a training plane, and this is runaway. So when we taxi the airplane, we have the propeller on, and there's a flight control at the behind called rudder. It moves to give the direction to the plane when it's taxiing. And the wind flies when it's in the air. There are basically three primary flight controls that come in picture. One of them, of course, rudder. It controls the yaw of plane. The second one is elevator, which helps in pitching the airplane up and down. And then ailerons, which, with the help of other two, helps to bank or turn the aircraft. And apart from that, there are secondary flight controls, which are not mandatory, but they are very important for easy maneuvering. So one of them is flaps. So whether you are a training pilot like me, or you're a pilot, or you have had an opportunity to sit next to the wings of a commercial aircraft, you must have seen surface protruding in and out when you're landing or you're taking off. So those are called flaps, and they come out basically to provide more lift. And then there's another thing, which is on the elevator most of the times it's called trim, that helps pilot to maneuver the airplane without too much stress while maneuvering the primary flight control. So these are kind of flight controls. And what happens with this flight control in terms of motion? So here I got suppose this is a rudder and it's moving like this. So in order for that rotary motion, we have actuator. So if this is hinged to a surface, the actuator basically moves this to and fro. So that's where the actuation comes in picture. And this actuation traditionally was pneumatic, like a long time back. And then since 1930s, they turned to hydraulic. Now in hydraulic actuation, there's a reservoir, there's a pump, there's a filter, and of course the incompressible fluid, which moves the actuator. And this particular system is very bulky. It requires lots of maintenance, and it requires lots of energy consumption. So with the advent of power electronics, the hydraulics are turning into something called EHA, that is electrohydrostatic actuator, EMA, electromagnetic actuators, as well as EVHA, which is kind of electrical backup hydraulic actuation. So in all these actuators, as opposed to the standard hydraulics, where the engine drives the hydraulic pumps, here we have got a motor in between. So the motor basically drives the actuator, and that's where we come in picture. So what happens because of this is that, number one, you don't have lots of energy consumption. Around 30% of the energy is saved in this process, depending on the which type of EHA or EMA you're using. And the second part is weight. There's a lot of weight that you can reduce. The third part is because you are transitioning from fully hydraulic system to either partially hydraulic system or mechanical system, you don't need to do lots of maintenance. So this is in the context of flying planes. It's very important because the lesser the weight you have, you can use more energy available. You can save it. So that's where it reduces the carbon footprints of aviation. So the power electronics used to drive the motor, that is part where microchip comes in.
Right. So you mentioned that transition, and there's a lot of system benefits here from the integration standpoint. You mentioned the maintenance. I want to go back to that weight issue, though. We're talking about huge amounts of weight here, right? Because that hydraulic system would scale up with the size of the plane, correct?
Yes. Yes. So, for example, something which is like 100, 150 HP, a training plane, there's not much complexity. But as you go to a bigger plane, there used to be huge hydraulic reservoir. There's a need of lots of hydraulic systems, centralized hydraulic reservoir going all the way to actuation, and that requires a lot of weight, a lot of maintenance. And with this, advent of EHAs and EMAs, that entire system is reduced in terms of complexity, in terms of maintenance. For example, the amount of times you need to replace the filter in the EHAs or EMA, there is no hydraulics at all. But that kind of maintenance is completely reduced to a larger scale, and at the same time, you have lots of maintenance issues that are taken care of just by the virtue of using this new age actuation.
Okay, and you mentioned some of the primary systems that are obvious opportunities to move to an electronic actuation system. Can you tell us more about the breadth of applications in which this type of system could be used?
As we can see, when we talk about the applications, we talked about primary flight controls and secondary flight controls. But then we also have landing gears, which kind of retracts and comes in during landing and takeoff. And then we also got deicing system. So in the cold environment, deicing for deicing actuation is used, and also door opening. Opening of a bigger commercial airplane. There's a lot of energy is required for that, and actuation is used there as well. And last but not least, in missile guiding systems as well as fighter jets, thrust vectoring is used. So in that application also, you can use our solution.
Okay, so when someone is considering implementing an electronically controlled actuation system, what are the primary design challenges, and what are some of the opportunities that they have to solve those challenges?
I think the primary design challenges, if you look at the overall speed of the plane, the overall passenger capacity, weight, the amount of pressure exerted on this flight control, they're tremendous, and that's why for smaller plane, the requirement in terms of kilowatts could be around 5 to 10. Whereas, as the size of the plane goes up, it could be around 250 kilowatts, north of 200 plus. And another thing is that you require very hard, very good reliability for this, and different topologies to maneuver the plane. So, for example, we have rudder. So rudder will just move in direction like this. And so you would need electronics drive for that. But for flaps, you would need the flaps to come in, come out, and you need a solenoid to hold that. So you need a combination of the inverter solenoid, as well as you need to take care of inrush current and aspects such as not making sure that your voltage is not going up. So for that, we use something called a brake switch. And we provide all this solution in one. And we have, if you look at the bottom end of our solutions, we give baseless power modules. On the higher end, we give our SP6 Li or high power modules. And the solution that we are going to discuss today is integrated actuation solution, which kind of combines all this facet in one for multiple applications. So applications wouldn't be just the, the planes, it would be EVTOL, it would be missile systems, commercial aviations, and Winnie will take you to more around, how we are designing our product to solve these issues.
Okay, so I know we offer some power modules there and other devices. Can you tell us a little bit more about what is integrated into these solutions?
Sure. So when designing this particular module, we had to consider all the relevant functions. Amit touched on them there earlier that might be required for an actuation system. So we built the three-phase inverter, the brake chopper, the soft start switch, and the solenoid circuitry all within this module. So, the result is really an all-in-one power module. The appeal of this module is that it can drive system efficiency using both silicon IGBTs and IM6 silicon carbide power semiconductors, all packaged in, a low weight, low profile package. We've optimized the inductances within this package, which allows for robust electrical operation. We've the materials that are used within the package allow for high reliability operation across a wide temperature range. This was all designed within an AS9100 certified design flow and meets the RoHS and DO160 requirements.
Right. Thanks, Vinny. So, can you just share with us what is the power range, the range of power that the modules deliver?
Sure. So this particular power module ranges from 5 kVA up to 20 kVA, and can operate at rated voltages of 270 or 540 volts.
Thanks. And you mentioned the AS9100 design process and the DO160 certification. So that's going to cover all the things we would think of in an extreme environment: altitude, temperature, vibration.
Yeah, exactly. So there are a lot of environmental conditions. We test between minus 55 and 110 degrees Celsius. Operating environment. We also test for temperature variation between those two temperatures. Being an aerospace application, low pressure or altitude testing is important. So we test this device up to 50,000 feet, which would be the equivalent pressure of 116 millibar.
Okay. Great. So what's next as far as integration in the module?
I suppose to facilitate all the functionality within the module, we designed a driver board or companion driver board that integrates with that power module. So it's fully compatible with the power module and provides all of the drive circuitry, bias power supplies, and telemetry signal processing required to, I suppose, effectively operate this power module within a system. It's galvanically isolated and partial discharge tested across the pressure range. It allows for integration with a single 15-volt supply, and the internal supplies are generated off of that, so that offers ease of integration within an actuation system. It also offers various different protections and safety features, like, for example, under voltage lockout, short circuit protection, DSATs, soft turn off, shoot through protection, and so on.
All right, thanks. So there's a lot to cover there, a lot of nuances and a lot of choices and trade-offs. What would you say are the main takeaways for someone considering moving to an electronically controlled actuation system?
So I think really the main benefits are, you're getting an efficient, fully integrated product in a compact package. It offers ease of integration. There's support directly from the design team and the people who know the product. It offers high reliability, and it's fully proven within the environmental conditions required in these aerospace applications.
Right, so if someone is interested in looking at these modules further and the solutions further, how should they get started?
I suppose the best way is to check out the website. So on the Microchip website, if you search for HPD, you'll find the product pages. There should be a link down below also. So from there you can check it out, and there'll be an option as well to request any additional information you might require.
All right. Vinny, Amit, thank you so much. At this point, let's go to Aaliyah and see if we have questions from our viewers today.
Yes, Eric, we do have a few questions from the audience. The first one is coming from Hilda from Bangalore. What sort of customization do you provide?
Thanks for the question, Hilda. So we offer, I mentioned the functions contained within the power module. So many of them are optional and could be excluded or not populated to reduce cost. So that this would be one of the optimizations or one of the customizations that we offer. We would also offer additional testing and screening to various different conditions if they were of interest in a particular application.
Yeah, and I would also like to add that apart from these are our standard solutions. We also got lots of legacy of providing non-standard solutions. So I'll just like to give look at one of our legacy modules. So this is a 5 kVA module. This is we released it a long time back, but it kind of shows our capability to give total integration, including the driver switch, and this particular module also had controllers. So not just standardization, but we can do complete derivatives as well as customization. So if somebody needs slightly different variation in voltages and wattage, we can cover that as well.
Thank you. Next question is a two-parter. This one is from Mario from Argentina. What are the other applications where I can use these solutions, and what are the market adjacencies?
Okay, so really these solutions can be used across a wide range of e-mobility applications. So, really actuators is quite a broad area. These particular ones are, while tested and designed to meet the aerospace standards, they're suitable for, ground-based e-mobility applications. As an example, we also have similar systems that are used for thrust vector control in rocket launcher systems. So really being designed and capable of these harsh environmental conditions makes them suitable for quite a number of other applications.
Great, thank you. Next question is from Rohan on LinkedIn. He's asking, what kind of support do you provide for this product?
Okay, so we provide technical support. Any support needed with integration of the product, both in the design phase and as in the production phase. So we would also provide support with choosing the right configuration and product for the application that the customer is interested in.
Great, thank you. Next question is from Bill on YouTube. Do you have options for lower voltage buses, 48 VDC for example?
These power modules are really designed for higher voltage systems. We offer them in 700, 1200, and 1700 volt variants. Our plan to offer them in 1700 volt variants. The modules themselves aren't really suited for low voltage applications, but there would be other products within the Microchip product family that would be more suitable in those cases.
Awesome, thank you. And next question is from Shruti from India. She would like to know, how do I buy the HPD module and driver solution, and can I buy it separately?
Yeah, so a very interesting question. So we'd like to reiterate that HPD power module, which has got lots of recognition for its innovation. So you can buy HPD module separately. So we have already released HPD module around more than 1 year back, and today we have released two variants of drivers, both for silicon carbide, that is MSiC, as well as IGBT plus silicon carbide diode. So we have released two variants. So those two variants, and then we'll also follow with other 10 variants to complete a portfolio. So the driver plus HPD combination is something that we offer as an integrated actuation solution. So that's a second option, which gives completely integrated solution. And HPD module is still there. So if customer wants, they have their driver already for HPD module, then they can buy HPD module, they can use their competence with their own driver. And we also give optionality to have our own driver, which we have released today, to give complete integrated solution. And the beauty of it is that this gives them tremendous design flexibility to the customer. So imagine designing driver, it takes around 1 year. So you got that ready from us. So you really don't need to bother about spending engineering resources, technical resources. Simply buy our integrated actuation solution. But we do not sell our driver board separately. So in sum, we sell the HPD fully integrated power module, what we call SP6 HPD in all variants. And with the release of our drivers, we can give complete integrated solution with the HPD module and the driver completely integrated from our factory.
Great, thank you so much. And thank you both for answering the audience questions today. Those are all the questions I have. And for the audience, if you have additional questions or comments, you can email us at livestream@microchip.com. And for our LinkedIn newsletter, it'll focus on today's coffee break episode. So go ahead and subscribe to our new and free LinkedIn newsletter to receive tomorrow's edition. Back to you, Eric.
Thanks, Aaliyah. Thank you again to Vinny and Amit. Thank you to our viewers for joining in today. Please visit us at microchip.com/coffeebreak, where you can see notifications about our upcoming seasons and peruse our previously recorded sessions. If you'll stay with us for just another minute, some news about our live stream offerings. This is the last episode of our 12th season of Coffee Break. We've continued with this program. We're really happy with how many people have chosen to join us during the live streams and ask questions and look at the library of material after the fact. So in addition to continuing with our Coffee Break series, we are adding a new live stream series called Designs for the Edge. We'll be kicking that off in May and June. It will focus a bit more on system level dynamics in key markets. I'll be hosting that program. I've been with Coffee Break for, I think, 6 or 7 seasons now. I'm delighted to have been able to participate in this. It's been a lot of fun meeting so many people within the microchip world and learning about their expertise. With that, we'll be transitioning to a new host, Dana Curtis. So I get to say to you now, Dana, welcome to Coffee Break.
Thanks, Eric. I'll be joining the Coffee Break team for season 13, which kicks off in June. So looking forward to getting to know everybody.
All right, and Dana, you have some experience with broadcasting at Microchip, hosting the podcast series.
That's right. I host the Beyond the Microchip podcast, which is part of the Microchip podcast network. So this is just another offering that we can get to know our products, customers, and applications better.
All right, welcome again. Again, we hope to see you at Coffee Break our next season. You're in good hands with Dana and Aaliyah, and I hope to see some of you in Designs for the Edge in May and June. Thank you. Have a good day.